There is no better energy efficiency measure that anyone can undertake, whether it comes to water heating, space heating, just being comfortable in your home, is air tightness. Build it tight and insulate it right. And God, the amount of things you can accomplish just by getting those two components perfectly, or at least as close as perfect as you can, is incredible.
Yeah.
Because once you insulate the whole envelope of the home, it becomes much, much easier to control what comes in and what goes out.
Hey everyone, welcome to this new episode of the Your Project Shepherd podcast. Another nail-biting, exciting episode where we dig into some building science. Heat pumps are something that you've probably heard of. I bet that when you hear that, you think about an air conditioning system, right? Because that's what most people think of when they hear the term heat pump. But today we're going to cover some other big uses, or some other newer uses for heat pump technology, and that is with water heaters and clothes dryers. And to talk about this with us today, I've got my friend for his second visit on the podcast is Voya. How you doing, Voya?
Doing very well, man. Good to be here. Made it home safely from Boston last night, so I'm glad to be here.
I started to say your whole name, and then I realized I forgot to practice your last name pronunciation. I was like, if I just say it, I'm going to butcher it, because I always verify that with people before I try to pronounce it, and I forgot to verify it with you. So Voya Milašinović. Milašinović.
Yeah.
Dadgummit. I was so close. Oh my gosh. And I've said it many times before, but I always choke on it when it comes time to say it on the air. So sorry about that.
Don't feel bad. I just got married about a month ago, but we've been together for almost 3 years, and she still can't pronounce the name properly. So I figure if it takes my wife 3-4 years to learn how to pronounce our last name, you're doing it.
I was going to say, was she brave? Did she take your last name?
Yeah.
Okay,
yeah,
so
she did.
So now she has to teach all of her friends and everyone else how to pronounce it.
And she's just gonna tell them first name. So
yeah,
I doubt she's gonna use it often.
Just call me Mrs. M. Well, thanks for coming back for your second visit. Tell me what you've been up to since we last visited. Last time when you were on, you had just a couple days before the podcast had a job change. You were with Mitsubishi for quite a while, and now you are with LG, right?
Absolutely, yeah. So I moved over to LG. Continuing the electrification advocacy and evangelism. So lots of fun stuff going on. Some new technologies coming out, some new things happening. It gives us access to pretty much a whole home electrification suite of products. And the company's moving in the direction that the future of electrification is moving in. So I'm excited to be there, excited to be part of it. Lots and lots of learning about their brand and their technologies, what they play with. But it has been a very, very fun last, about 4 months or so now, 5 months almost.
Yeah.
And then just came back from the Dr. Joe Stieberek's summer camp for building science misfits.
That's awesome.
Hopefully that catches on. That's not what. But it was an amazing week up there. Got a little cool last couple of days. I was not expecting that.
I'm jealous.
I wasn't jealous. I didn't bring jackets or anything like that with me. So I'm sitting there going, should I run into town and go buy a sweater or something out here?
Where is that? What town is that in?
It's in Westford, Massachusetts. A beautiful little town about 45 minutes northwest of Boston. Dr. Joe's it's the Building Science Corporation headquarters is there. They've got a beautiful spread that they put on this Building Science Symposium at annually. The amount of just brain power present at this event it's something I look forward to every single year, to just be able to go there and maybe just through being around them, absorb some of that brain power, some of that knowledge, because it just oozes.
I would love to go to that sometime soon. I saw that my friend Miguel from Tamlin was there. Mm-hmm. In fact, he was posting some pictures of a barbecue cook-off. Had the Texas team doing barbecue and impressing all the New Englanders with our superior barbecue.
Oh, the food is phenomenal. every single night. I told my wife, I was like, baby, just understand, I will come back to 20 pounds heavier. We'll work on that when I come back, but just know that it's happening because it's a fun time.
Yeah. Well, speaking of fun times, new technologies, like I said, we're going to talk about heat pumps today. And again, people think of air conditioners when they think of heat pumps and the technology's been around for a long time. In the 1980s, when I was a kid, my parents had a heat pump in their house in North Carolina. But that technology's come a long way. It's evolved and it's transitioned to different uses now other than just air conditioning. So for people who aren't familiar with heat pump technology, in the simplest terms, what is a heat pump and how does it work?
Everyone has a heat pump in their home right now. If you have a fridge in your kitchen, you have a heat pump. All a heat pump is just a simple device that moves heat from one place to the other. An air conditioner essentially moves heat from inside the house out.
Right.
That's it. It's a one-way device. All a heat pump does is simply add another component, a reversing valve, that simply just switches the process around. So the same piece of equipment now, instead of taking heat from inside, removing it and putting it outside, can now take the heat from outside, put it inside the house. And like you said, technology has evolved. Just like cars, computers, right? I remember my first computer being, a Commodore 64.
I had one of those.
Oh my God, it was amazing. But it was like the size of this desk and you had to hook it up to your TV and it was massive and it was slow and cumbersome. But for us, that was like the future. Heat pumps have moved alongside all other technology. So we're able with heat pumps now to remove heat from air, even when it's like 13, 15, 20 degrees below zero outside. There is still heat in that air.
Right.
We can efficiently move that heat inside, and it's much more efficient than using, say, electric strips or even gas, right? We're getting more energy units by using heat pump technology than by just simply either burning gas or other fossil fuels or just using.
And one of the big knocks on heat pumps used to be in colder climates or in the winter, they just weren't as efficient, and they had to switch over to that backup heat strip all the time, which sucked electricity. But the newer models, the newer improvements to the technology have really changed that to where it's got to be pretty freaking cold for it to have to revert to the backup heat strip now.
Oh, absolutely, yeah. Like I said, most of your inverter-driven heat pumps right now at 5 degrees Fahrenheit, they're still operating at 100% capacity. You don't need to go like maybe -10, -13 before you really start to need that backup strip. And for us down here in Texas, we'll never need it, man.
We'll probably never need it, right? No. We still have a lot of AC guys because we switched to installing all heat pump units on our new constructions. And the AC guys will, at least a lot of the old school guys, right, will still tell you that you've got to have that backup heat strip. And they'll sell that, right? But I would say most of the manufacturers, if not all of them, the current technology, you really don't have to have it. It's kind of it's something they're putting on there as a worst case scenario, but in reality, you could just save that money.
I don't have backup heat strips or backup heat at my house. My mom and dad, and I love my mom and dad. My mom and dad have a inverter-driven heat pump in their home. It is slightly undersized, so it actually performs better in summertime by removing more moisture. And even with it being undersized, they've gone through 5 winters in that home right now. It's a 1994 built home, so nothing spectacular when it comes to air tightness and insulation levels. And they've gone through, like I said, 5 winters with no need for any kind of backup heat. Proof is in the pudding.
Exactly. And so you mentioned it was slightly undersized and it provided some additional dehumidification. That's one of the big benefits to heat pump systems also is you get more dehumidification. Actually, with any air conditioning system, you're going to get some level of dehumidification, right? Mm-hmm. But heat pump systems in general are better at that. And then when you start looking at, you got a heat pump, clothes dryer, heat pump, water heater, you're adding that additional benefit throughout the house.
Absolutely. So a typical heat pump water heater will provide anywhere from a 1/4 ton to almost a ton of heating capacity in that it takes that heat from inside the house and moves it into the water. That cools your house. So it's an additional cooling system in summertime. So for, those folks that have a good heat pump water heater and have it in the conditioned space, which is key with water heaters, and that's something we can talk a little bit more in detail. But if they have it in there now, they also have an additional pony system. So they can have their AC sized for the majority of the year instead of sizing it for that 104-degree day. And then they have the water heater that just gives them the ability to have that extra, half ton, quarter ton to a ton of capacity for those 104-degree days without having to be oversized with their AC system.
Yep. One of the other big benefits toward all of these uses, water heaters, dryers, AC, is we're eliminating more penetrations through the building envelope, right? Mm-hmm. Preventing the combustion air and exhausting the carbon monoxide. So you're eliminating that vent for your water heater, the vent for your dryer, because the heat pump dryers are ductless. You're getting rid of the flue pipe for the gas on your furnace. So that's often 3 or 4 inch holes through your envelope that you're getting rid of.
Absolutely. And as a building science geek, you're talking my language now. You're getting me excited. When it comes to ducted clothes dryers specifically, let's talk gas. What most people don't realize is that when that gas dryer runs, that's roughly between 800 to 1200 CFMs that it's exhausting. Your house is going negative pressure.
Right.
Where is that makeup air coming from? Where's it coming through?
Yep.
And if any of your listeners have done a remodel on their existing home and opened up a wall, an exterior wall to be specific, they've seen what's in there. That's what's filtering your makeup air that comes into your home.
Right. It's sucking the air from all those little cracks and crevices and
insects.
We like to say all the roach poop in your walls. Exactly. All that air is getting filtered through that.
All of those things. That's what's filtering your air coming back into your home. And 1200 CFM is a lot of air movement.
Yeah.
That's what's coming into your house. That's what you're breathing just by running a clothes dryer. So when we go to heat pump clothes dryers that are ventless, we eliminate one more additional piece from our home that can make it go pressure negative and cause all of that air to coming through unchecked little cracks and around your ceiling can lights and, through that insulation in the attic with all the squirrel poop. Let's add that too. There's a lot of things that we have to think about how we live and what it is that we breathe. These technologies are being designed in such a way to help make our homes healthier.
Yeah. And indoor air quality. So you're getting all that combustion, all that gas combustion out of your house too. We've eliminated on a lot of new homes now by using induction cooking. That's one big emission source in your house we're getting rid of by switching to induction. So the other low-hanging fruit is the furnace, the water heater, and the clothes dryer. I mean, really, those are the main 4 sources, or the only 4 sources usually, of gas combustion in a house. And so if we're getting rid of those, we're making the air that we breathe cleaner. It's improving our health. If our kids have asthma, it's helping that. I mean, there's a lot of benefits to getting that combustion out of the envelope.
There's benefits beyond just health. For every woman listening, and every guy that likes to cook like I do listening, the way I convinced my wife that we're going to get a induction cooktop, I spilled stuff on the stove. Wasn't on purpose, but I cleaned it up and it was so easy to clean because there's no hot surface.
Right.
Nothing burns and sticks. It was amazing. She looked at it. She was like, "Ooh, can we get one of those?" You bet you we can.
Yeah. And it's smooth and flat too.
Yeah. But let's talk about water heaters more. I mentioned just a minute ago that one of the big things about what we need to change as we build homes is where we place water heaters.
Yep.
Down here, we're used to 2 places. We either put our water heaters in the attic or we put our water heaters in a garage. In the South, putting a water heater, especially a heat pump water heater, in a garage does have some benefits. It'll help keep your garage a little bit cooler. Okay, how often are we?
Who cares?
Who cares? Yeah. If I'm going to spend a lot of time in the garage, that water heater is not going to cool it down enough. I'm still going to get a mini split for the garage. I'm going to turn it into a man cave or a shop or,
right.
I like to toodle on my Harley and work on it and love on it a little bit. That's my other girlfriend. But I like to have my mini split in there because the water heater can't keep up with the heat.
Right.
So why not look at putting the water heater in the conditioned space? So like I mentioned, when I was at the building science summer camp, I was talking to Gary, and Gary Klein is a genius when it comes to water systems. Like most people that play around with designing plumbing and water systems know who Gary Klein is, have heard that name. And we were just having a discussion about like, where do we place these? And the ability to put in a heat pump water heater in, let's say, a space like a pantry that's next to the fridge, and then pull the air that you supply to the water heater from the side of the pantry where the fridge is, because fridge generates heat. Your kitchen is always generating heat while we're cooking, while we're congregating. Let's take that heat and help make the water heater run more efficiently. And then let's put the air, the cold air off of it back in the kitchen and in the pantry. Now we have a European style cold room in our pantry, which is super, super nice. If I can reach in and grab you a beer and it's nice and cool without, that's a good thing, right? But secondly, we're now adding that little bit of cooling in the space where we need it most. And if we think about it, when are we going to use the most amount of water? In the evening, when everybody's coming home from work, getting ready for bed, right? When are we generating the most heat in the kitchen?
In the evening.
In the evening, when we're cooking our meals.
Or maybe the same thing in the morning, and for both the same reasons, right?
Absolutely.
Yeah.
You're still making breakfast, kids are taking showers, getting ready, going to school.
Yep.
So we're now using those passive principles to help both the fridge work more efficiently, to help the water heater work more efficiently, and to overcome the one place where typically when we design and we do manual J's, why do we have to select a space as a kitchen?
Because it's a big heat load. It's a big design consideration because of the heat load, yeah.
We've got appliances there. We're generating humidity there. Those are all things that we now have to overcome with our central AC.
If there's makeup air coming in the kitchen, you're dumping in warmer outside air via makeup air.
Absolutely. Yeah. And now you have a little unit that's right there and helps overcome all of that, and it doesn't affect the rest of your house.
Yeah.
Runs more efficiently.
Yes.
So we just have to think about, where do we put things? And all of a sudden, the sky is just the limit.
That's a great point. It's funny. I had not thought about it like that. But a house that we're building right now that we were discussing a few minutes ago, it's a demonstration house for another company. But this was unintentional. But now that you say this works out that way. We've got our refrigerator, in the corner of the kitchen, a few feet away. We've got our heat pump water heater. Mm-hmm. We've got our range, and we've got our washer dryer right there, all within 8 feet of each other in this one area of the kitchen and pantry. And so that's a great benefit that I hadn't even thought about.
No, I bet you that water heater was also designed to look nice, so it actually is meant to go in conditions.
Yeah, and that's something we were chatting about before we started recording, was that, like anything, there's a big variety of price points and quality points for these products, right? You can get we'll call it the entry level or the base model heat pump water heater that you can probably get at a big box store, that, they kind of look like a traditional tank water heater. It's not something that you necessarily want to have in your space where people are going to see it all the time. It's not meant to be pretty necessarily. But then companies like LG are making a very attractive heat pump water heater unit. There's some other companies that are bringing some stuff to market that looks really sharp. It looks like it's meant to be within that space. And so, yeah, I mean, these companies are starting to put some thought into, if we want people to have this in a conditioned space, if people are going to be looking at it, we want it to look nice.
Oh, of course, yeah. Ours is nice in stainless steel. First time I looked at it, I saw that thing, I was like, holy cow, it's a Cylon. And if you're a fan of Battlestar Galactica, you'll know what I'm talking about. And the next thought was that it's probably going to kill me in my sleep. Thought was that I still want it anyway, because it's just cool and sexy. And it's like, it's something you want to show off. And it's designed to look that way specifically to encourage people to bring it into the space so that it becomes efficient. Like we actually start to use the technology in a way that it was meant to be used.
Yeah. Does the LG unit have an outside condensing unit, or is it an all-in-one package?
No, it's an all-in-one package. So it's outstanding for new construction and retrofits. It'll fit pretty much anywhere where you have a standard height.
Awesome. Yeah. So some of the units, well, most of the ones that are currently on the market, again, the ones that look like a traditional water heater are an all-in-one unit. Sounds like yours is an all-in-one unit. I've seen some other brands that have an inside-outside setup, just like a mini split would. Essentially, it is a mini split. It's just a water heating mini split.
Yeah. There are several companies that do it. We have product that does the same thing. Personally, I prefer the all-in-one.
Installation's easier.
Cost, installation's easier. It fits in places where you would typically want a water heater, but then we can use our monoblock product for other things like, space heating and cooling. And it's essentially like a mini heat pump chiller.
Yeah.
And I'm actually pretty close to putting one of those in my house so that I can just kind of play with it and see how it works in our climate. But we can do a whole nother episode talking about monoblock and about hydronics, because I really do feel that when it comes to space heating and cooling, hydronics has a huge potential to be the future.
Yeah. And I've seen some, I haven't seen any here in the U.S. yet, although they may be in the U.S. and maybe LG is doing this, but I've seen some companies overseas, at least right now, have some combo air conditioning units and water heating units. The same heat pump is doing both tasks.
Mm-hmm. Yeah, we have them. We have them available. They're really nice. They're super efficient. They can work just as well as the all-in-one water heater. It just really all depends on what is your application, what it is you're looking to do, and how are you wanting to design your system. So it just opens up multiple possibilities to fit every need.
Yeah. I mean, so design is a big consideration. So like you said, ideally they're within a conditioned space. So it's just one of these things that architects, designers, builders need to have some advanced planning, with a traditional tank water heater or with a tankless water heater. A lot of times the placement on the water heater is kind of an afterthought. It's like, during architectural design, there's no thought given really to where the water heater is going. Mm-hmm. It's just kind of up to the builder and the plumber in the field. We'll just stick it in the attic there. We'll slap it on the outside of the house here. We'll put it in the garage, whatever. So one thing about these, if you're going to reap the full benefit of it, is you've really got to plan on where you're going to put it during the design process.
Yes. And, wow, what a surprise that if we simply just pay a little bit more attention to everything during design process, rather than putting a little note in, we'll figure it out down the road, things all of a sudden start to not only look nicer and look like they were actually done intentionally, but believe it or not, it starts to become a lot cheaper because you can plan for it.
Yeah. A note that I see on plans a lot is, a contractor to verify location of equipment in the field. And it's like the architect's just kind of passing the buck.
Yeah, absolutely. What a better way. Is there a better way to really just ensure that let's go ahead and let 3 contractors down the road decide how things are going to look for our design.
Yeah. Or how it's going to function, how efficient it's going to be.
Well, yeah, of course. I mean, if you want to run your shower for 10 minutes before you get hot water, go for it. But if you'd like to get your hot water nice and quick and not have to use additional pumps and everything else, follow Gary Klein. Teach you a thing or two on how to design a plumbing system that just works really, really efficient.
So hot water delivery rates, that's something I wanted to touch on, because with a tankless or traditional tank, you can do a recirculating pump or one on a timer or whatever. What are your thoughts on heat pump water heaters with hot water delivery, especially if they're some distance from the fixture? That's one concern that I've heard is, okay, if I've got a 60 or 80 gallon heat pump water heater tank that's a floor away and 50 feet away, is the speed at which that water is going to get to the shower?
So let's cover, that's a great little myth, and I love myth busting.
Good.
I kind of wish that show was never. But water is water. So at the point where that water is getting heated, I don't care whether it's being heated by gas, by electric, by a heat pump, or if it's a pass-through water heater. If it's 70 feet of pipe exposed in the attic from the point of where your water is heated or stored, to the point where you need to use it, you still have 70 feet of pipe exposed to conditions in the attic. It's still going to take the same distance.
Right.
So really now we need to talk about like what is the pass-through, the first hour pass-through rate for that water heater. Instant water heaters, or I guess the tankless, they're not really instant. I mean, they're instant as in a sense that they start to heat water when you trigger them. And they can do the job very, very well. They're just super energy intensive. They don't maintain, but they're super energy intensive when they run. Okay, so how do we overcome that? Well, just build a tank that's better insulated. I mean, water is a great medium for retaining heat energy. And if we just simply insulate the tank well, then you got benefits right there. I mean, you're using less energy, and it takes a very, very small amount of energy to maintain temperature in that tank. So now when we start using the water, looking at the LG's water heater, for example, and I'm not going to bring up other brands or anything like that. All of them get fairly close. But for example, ours, we have a 50-gallon tank, and then we have a 80-gallon tank, and our 55-gallon tank has a first hour pass-through rate of, I want to say 67 gallons. And then the 80-gallon tank has a first hour pass-through rate of 97 gallons or so. All of that at a COP of 3.93. So it's super, super efficient, very low energy use, yet it delivers water at essentially the same pass-through rates as the older product did. Yeah. It just holds it much, much better because it's a better insulated tank. So the delivery now just comes down to how do we design the plumbing system? Am I placing my water heater in a place that's kind of central to where most of my water is going to be used? Or again, am I sticking my water heater in the garage, which guess where do we always put the garage?
The corner of the house.
The very furthest place away from the primary suite, right? Because primary suite, that's where the money and the honey sleep. We don't want to hear the water heater. We don't want to hear the car in the garage door coming in and opening up and closing. So we put our primary bedroom, primary bathroom as far away from the water heater. And then we wonder why does it take so long for water to get through. And then we put recirc pumps and all kinds of stuff to overcome things that can simply be overcome by smarter design. Yeah. Put the water heater closer to where you need it. It's going to be much, much better for you.
But can heat pump water heaters work with a recirc pump? I mean, I've heard that you're kind of defeating the purpose if you're doing recirculation on a heat pump water heater.
I mean,
because you're making it work more, essentially.
You're defeating the purpose doing the same thing with a gas water heater. It's
true.
Physics still stay the same. So does it work with a recirc pump? Yes, absolutely it does work with a recirc pump. Would I put a recirc pump on a heat pump water heater? Sure, why not? If the consideration or the design is such that I have no choice and I have to have 70 feet of pipe.
It's like a retrofit situation where you don't really have a choice on where that's going.
Yeah, absolutely. Put a recirc pump on it, but make sure that your recirc pump is triggered by temperature and not by time, because time is dumb. It runs when it needs to run, whether it should or shouldn't. So if you can trigger your heat pump with a temperature sensor, then yeah, I mean, you're sending water once it starts to drop down in temperature a little bit, sending it back in, reheating it. Again, remember, the heat pump water heater is efficient, super efficient. And the less of a temperature rise it has to overcome, the more efficient it becomes. So if we're just recirculating that water back through to maintain tank temperature, it's not going to be as efficient on the electric side as it would if you didn't have a recirc pump, but you're going to save a whole bunch of water. Yeah. So it's a trade-off.
And you should be insulating all of your water lines now. Like kind of the old way of roughing in plumbing was you only insulated the cold lines. Mm-hmm. And even some people only insulated cold lines in the attic. Mm-hmm. Whereas now a lot of builders, this is what we're doing, and I would recommend that everyone do this, is insulate all of your water lines in the attic and the wall everywhere, and that's just going to help you out.
I agree 100%. Anything that you have to maintain at a certain temperature should be including our homes.
Yeah. And having those pipes that are running through your attic within conditioned space is also going to help.
Oh, yeah. The worst thing that we ever did in the building industry is a vented attic in the South. That's absolutely the worst thing we can possibly do for ourselves, for our energy use, and for our health is a vented attic. So all of you guys, including yourself, including Toner and things that he pushes, all the builders that are building right now and are building to a better standard and a healthier standard are insulating the attics. They're bringing everything inside the envelope, as we call it, because once you insulate the whole envelope of the home, it becomes much, much easier to control what comes in and what goes out. So there is no better energy efficiency measure that anyone can undertake, whether it comes to water heating, space heating, just being comfortable in your home, is air tightness. Build it tight and insulate it right. And God, the amount of things you can accomplish just by getting those two components perfectly, or at least as close as perfect as you can, is incredible.
Yeah. I've said this before. I still live in a 1950s house that I remodeled. And yet the only nice thing about the uninsulated attic in my 1950s house that I haven't had a chance to seal up yet is if I want to take a shower in the summer, the
water's hot.
The water's already hot.
Oh, yeah, it's great.
If I want to wash my face, the water's already hot.
It's already hot.
Or in the winter, if I want some cold drinking water, it's already cold. So what are some downsides to heat pump water heaters? Or I don't know if downsides is the right word, but what are just some considerations other than design, having a good location on where to put them? I think upfront acquisition cost is the first thing that comes to mind for me, just because, basic gas and electric water heaters are so cheap. I mean, they're like $300 or $400, right? Tankless water heaters have come down in price. I used to tell people plan on $2,500 for a tankless. So now you can go get a tankless with all the parts and fittings for maybe $1,500, right? Heat pump water heaters still have a higher acquisition cost, right?
So let's call it an average of $1,500 to $1,800 or $2,000, right? Ours falls kind of right in the middle of that number. So it's cost comparable to every water heater out there, just about, other than the cheap
to a tankless system. Yeah.
But first, cost is a pet peeve of mine.
Okay.
You live in a 1950s home, right? So the efforts you've had to undertake to make it more efficient, so you're not spending $800 or $1,000 a month on utilities. When we concentrate on first cost only, the operating cost becomes exponentially greater.
Right.
And when I talk to builders and contractors, they go, oh, but, my customer can't afford it if I give them something better. Can they afford to live in whatever it is that you're giving them? Does it matter if I can qualify for a mortgage and spend every penny I have to just get right where I need to be so I can get my mortgage right? If I have to now decide, am I going to live in this home comfortably, or which utility bill am I not going to pay? Because it's costing me a fortune. So yes, the first cost of a heat pump water heater is going to be slightly greater, but the benefits, with it being roughly 60 to 70% more efficient, they kind of pay for themselves pretty quickly, right?
Right.
The other thing to think about and consider when customers are going out and purchasing a heat pump water heater, do your research. Learn simple math. BTUs equals wattage times COP, or UEF on water heaters, times 3.412.
And tell us what COP means for people listening.
Coefficient of performance, okay, or uniform energy factor on water heaters is UEF. So you want to look and calculate at all heat pump water heaters, just like all air conditioners, are not made the same. Look at what is the wattage of that heater, multiply that by the COP or the UEF of that heater, and then multiply that result by 3.412. That's going to give you your BTUs per hour that water heater is actually putting in the water. If your heat pump water heater at design, which is like 67 degrees ambient temperature, 58 degree water temperature inlet, 4,000 BTUs of heat, guess what? You just bought yourself a really expensive electric, because that thing's going to run the electric strip like 90% of the time. You may have saved a couple $100, but you just spent a couple $100 a month more just to run that water heater. But if you get a water heater that may cost you more, but it's putting out, 11, 12,000 BTUs, 10,000 BTUs, 8,000 BTUs of heat into that water, that's now a lot more buffer before that backup heat element ever has to kick in. And if that water heater can give you that capacity and run on heat pump mode only, down to like 20, 25 degrees, but you put it in conditioned space.
It's never going to get down to 25 degrees.
It's never going to get there. You're never going to have to use your backup electric unless you have a whole bunch of people coming over for Christmas or Thanksgiving and you're using a ton of water. So be smart. Do the math. Do the research. Most companies nowadays will publish their submittals for their product where you can go in and see exactly what the performance is. How did they test it? What are the test criteria they followed? Do the research. Do the math. An educated consumer is a powerful consumer.
What about noise on heat pumps? This is a concern that I've heard from people, is the heat pump water heaters are noisy. What's your thought on that?
So to stay positive, we'll say our water heater is only 40 decibels of noise when it operates at 100% capacity in heat pump mode. So that's the loudest it's going to get. Compare that with roughly 35 to 40 decibels of noise that your fridge produces.
Okay.
So if you don't mind having a fridge in your house, you won't mind having one of our water heaters in the house. I don't know what noise levels other heaters produce. I can read and stories, but I don't have one in my own house of any other brand, so I can't speak for them.
Yeah,
I have heard.
I was going to say I've heard some, and they've got to be approaching double that.
I've heard ours, and it's super quiet. I have not heard others, so I can't really speak for them.
It's a very diplomatic way to put it. Another consideration that I had made a note about was, and this is just for a retrofit situation really, is if you're looking to convert to a heat pump water heater, is just space in your breaker box. So if you're in an older home and you want to retrofit, you got to make sure that you've got the available capacity in your breaker box. What size breaker does yours take? 30 amp? Mm-hmm. Okay. So if you're in a house that's already maxed out on your breaker box, maybe a consideration for you.
I wouldn't do heat pump first. I would follow the simple principle of AWE. A-W-E. Audit, because you got to figure out what you have. Weatherize, again, make it tight, right. Then electrify. I'm in the electrification business. I get paid to sell electricity running appliances. So if I'm telling you, first measure what you have, then tighten up and insulate what you have. And once you've done that, only then electrify. I'm doing it because I want the best chance for our electrification products to work. If we electrify first, just because there's rebates available, and then go to try to figure out, well, why is my electric bill high now? You just wasted all that money and you messed up everything for the next 10 years for yourself.
That's great advice.
Audit, weatherize, electrify. If you're in an old home and you really want to electrify, which I love electrification. I think it's better. I'm a hunter. I'm a fisherman. Conservation is in my heart. Conservation is in my blood. I want to be able to use those resources with my kids and my grandkids and their kids, right? The only way we maintain those resources is if we utilize and conserve them appropriately. Same thing is when it comes to energy. I want to conserve my dollars. So yeah, I'll spend a little bit more money now, but I'll live in a healthier home that costs me less money to operate, and in 10 years, I'll come out ahead. So what I would advise is there is a company, and I'll go ahead and name drop if you're okay with that.
Sure.
Okay. Span. So look up Span.
Great panels.
Outstanding panels. I don't get paid by them, by the way, which if Karen's listening, Karen, I'd like my commission check.
If you want to send the check, go ahead.
Yeah, go ahead and check.
We also accept sponsorships on the podcast.
But they've designed a product that is really specifically intended for smaller homes or smaller electric service homes to be able to retrofit and electrify, because it now becomes a full energy management system. We typically size our electric panels to be oversized, like way, way oversized. I read an article somewhere, I think it was Rewired America, that published an article. They did a multi-year study, and they found that something like barely 25 or 30% of the total capacity of the panel ever gets used at the same time.
Yeah.
And in some cases, it's even less than that.
Yeah.
So it is a ridiculously oversized panel. And then you want to electrify and you're like, oh, there's no more room. There are rebates right now.
Audit.
Yes. Audit first. There are rebates right now. There are tax credits available for changing out your panels to a smart panel. It gives you benefits beyond just being able to electrify with a smaller panel. But for builders, you can build a 4,000, 5,000, 6,000 square foot home, which normally you would put in what, a 320 or a 400
amp service these days. Yeah.
That's costing you what, an extra $4,000 or $5,000?
Yeah.
Easy. put a span panel in and you can do it with 200 amp service.
Exactly. You actually stole my next point. We did a whole podcast on this a few months ago. Obviously, you didn't listen to it, but that's okay. It's okay. Yeah. So we had Dylan Rutt from Savant as a guest, and Savant has an energy monitoring system as well. That's a retrofit product. And we talked on that show about how panels are greatly oversized, and if you're managing your loads, there's no need to have these 400 amp panels these days. So fantastic point. Totally agree with you on that. So my next comment was actually going to be on new construction. Kind of this, I don't have space in my panel shouldn't be really a thing. Or again, if you're looking at adding all these electric products to move toward electrification, and builders are like, man, I just don't want to have to put 300 and 400 amp panels in my houses. Well, you don't have to.
You don't have to, absolutely, yeah. And like you said, Savant is a great product. It's an energy management system. And there's language in the code that allows for use of an energy management system that completely bypasses the standard formula for sizing electrical panels.
It's the mentality of doing things the way they've always been done, and it's a degree of laziness, to be honest with you. It's kind of not wanting the change is the reason that electricians and even municipalities that require electrical reviews. So City of Houston doesn't require any kind of load analysis, but here in our area, City of Bel Air, West University, Memorial Villages, all these places require you to submit a panel diagram and a load analysis. And those code officials probably aren't looking at energy management systems. They're just looking at this house needs a 400 amp panel.
But the language is there, and it's simple and easy to just point to it.
There it is. So as a builder, architect, designer, electrician, we can just point to those building officials and say, hey, I know everyone else is doing it this way, but here's a better way to do it.
Yeah, and here's the code language that allows it. No, I love it. And it's we can electrify. And again, I love electrification from just the perspective that if I can put some solar panels on my roof and I can throw a small battery backup on my house, and pretty much everything I run is efficient and electric, and my home is nice and tight and weatherized, I don't care if power goes out for a couple of days when a storm comes through. I'm up and running. I'm comfortable. Right? And I got 4 kids. I want to make sure that they're comfortable and that I'm providing for them the best environment that I possibly can. That's my drive. That's my goal.
Yeah.
Now, if somebody wants to do it with gas, more power to you. I don't mind. I live in Houston. We are gas. We love gas, right? It's what pays the bills for most of us.
Right.
The other thing also that we need to pay attention to is that the way trends and the markets are moving, gas isn't getting any cheaper. It's still fairly cheap for us, but it's getting more expensive year over year. And as more people choose to electrify, there now becomes less people paying into the infrastructure maintenance of the gas systems, yet that infrastructure still has to be maintained. So the share that those of us who still have some gas in our homes, which I still have some gas in my home for now, but the share that I now have to pay to maintain that infrastructure becomes greater because there's less people to share it with.
Right.
And as time goes on, it's only going to grow and grow and grow. So start thinking about it now. Start planning on it now, because like we mentioned earlier, anything planned is cheaper than when you have to go, oh crap, it's busted. What do I do now? Well, now you pay whatever they want you to pay because you ain't got no choice.
Right. I mean, when I'm having the conversation about electrification and about choosing these heat pump products, for example, I'm not here in Houston on houses that we're building. I am definitely not having the argument that this is cheaper than gas, because it's not always cheaper than gas. And I'm not always having the conversation of we've got to eliminate gas from our homes because, again, people in our market make so much money from gas, oil and gas, that's not a conversation they want to have. But I've found if we focus on talking about health benefits, indoor air quality, things like that, that's for our market, that's a great argument. We already have crappy air quality in Houston. What can we do to clean up that air quality in our homes? So I find that's a much better discussion especially with my higher end home buyers in Houston, Texas.
Oh, absolutely. There's always going to be a use for gas. When I built my last house, built it all electric, but I still had gas. It's way, way better at heating the hot tub.
Right.
Electric is.
Yep.
So there's still, you want to run a backup generator. Like, look, we sell backup batteries at LG. They're a great product. Is it for everyone? No. Is it for every place and every municipality? Of course not. But if you want to run a backup generator, you still need gas.
Yeah. Or if you want a gas grill in your backyard, I mean, even though, let's be honest, charcoal and wood burning is so much better, but for cooking,
it's so much better.
It does. It's
I don't
so much
even
better.
own a gas grill. I'm sorry.
Same here.
I've been converted to a Texan baby or charcoal grill. That's it.
Exactly. I'd be fine with having no gas in my house, to be honest with you. So, sorry. So let's hop over and talk about heat pump dryers a little bit. It's something that it's newer to the U.S. market. A lot of people have never heard of a heat pump dryer. They're like, "What's that?" But they've been in use in Europe and Asia for a while. Like a lot of these technologies, these things are coming from these other parts of the world. And one thing about heat pump dryers, same technology that we've been talking about with the AC systems, with the water heaters, the same concepts. But one of the things that's very different about a heat pump dryer is that they are ductless. Again, we mentioned this earlier. You don't have that 4-inch dryer vent going through the wall of your home. But I think one of the reasons they have been super popular in Europe and Asia, and in their smaller living quarters oftentimes in limited space to put something, they don't always have a way to run dryer vents wherever they need to put a closed dryer. It's a space consideration. It's a design consideration over there for them. And so they've caught on quickly over there because you can stick a heat pump dryer, a standalone dryer, in a lot of different places. And so for them, it's been partially a space thing. But for us, again, not having that penetration through your envelope is a huge thing for me as someone who's trying to build a tight home. To me, that's one of the biggest benefits.
Well, that, and like we talked about earlier, you're not adding a fan that sucks air out of your home that you spent money to condition,
right?
Just so that you can replace it with unconditioned, nasty air coming through all the crevices.
Right.
So design considerations aside, because yes, most of the world does not build the way we do. They don't build with wood frame. They will build with concrete and block, right? It's a lot harder to install ducts, but energy is also more expensive. Why dump the energy out after I spent money to condition it? So they are ductless, they are ventless, so they simply, whatever air goes in stays inside the space, but they also dehumidify that air. So they help cool the air a little bit, they dehumidify the air, and then most of them nowadays, they just simply need, a standard 115 volt circuit, 15, 20 amp in some cases, depends on the manufacturer. And they're going to need a 3/4 inch drain line. It becomes easier. Like you said, it becomes easier to manage those penetrations. There are also now combo units that, we have one. There's a few other manufacturers that have one that work well.
Washer dryer all in one.
It's a washer dryer all in one.
Yeah.
They are intelligent. They have the ability to weigh the load. They have the ability and sensors to actually sense the type of fabric and the color of fabric that's there. They automatically weigh in the exact amount of detergent needed, the exact amount of either bleach or softener needed, based on the weight of the load and the type of fabric. They complete the wash cycle, and then they immediately switch over to drying cycle.
Wow.
And once it's done, it notifies you through your app that, hey, load's done. Now, in the past, there have been, again, technology starts, it's a good idea, but maybe it doesn't work as well in practice as it did on paper, but it slowly evolves. So in the past, one of the biggest complaints about heat pump dryers was that they just didn't dry the clothes.
Yep.
Couple of things. One, yes, they did not have sensors, so they did not dry as efficiently and as effectively as, let's say, a gas or an electric dryer. But the other is perception. When I grab a piece of cloth that is still slightly damp, but 100 degrees, 120 degrees, it feels dry.
Because it's hot.
Because it's hot. But if you've ever had to clean a lint filter after every use, they really mean clean your lint filter after every use. Guess what all that lint is? It's the clothes you spent money on, falling apart, getting hot, and then getting caught in your lint filter and ended up in the trash. If you look at some of these newer products, the washer dryer combos or just the heat pump dryers, that lint filter has to be cleaned maybe once a month. It's much, much gentler on your clothes. Your clothes last a lot longer. Yes, when you pull the clothes out, because they're cooler, they will feel like they're slightly damp. Fold them or just let them outside, let them sit on your couch for 5 minutes. You no longer feel the dampness. They're no longer damp.
Yeah.
Because they have sensors built in now. They adjust the runtime to make sure that the clothes are dry the way they're supposed to. So technology has changed. It's grown. And if you look at, let's say, for example, LG's combo washer and dryer, it's a single unit. It's 5 cubic feet, right? So I can wash a king-size comforter in that thing without problems. And it's small footprint. It's basically the size of a single unit right now. The cost of them has come down drastically. So now you can buy that combo for slightly cheaper than buying separate front load washer and front load dryer that can do the same thing.
Wow, that's crazy.
So it becomes actually cheaper to go this way now. And for a builder, it only needs a 15 amp, 120 amp circuit.
Wow.
That's it. Now you're saving the 30 amp spot that you needed for your heat pump AC, or you want to use induction cooktop or something. There's you a 30 amp circuit right there that you no longer need in your utility room, and you can use it somewhere else, or you can just eliminate it altogether.
Wow, that's fantastic. Yeah, Matt Reisinger put in another brand, I think it was a Miele, that he put in his house here a few years ago when he built his new house, and I was asking him how he liked that. He said, yeah, again, this was probably 5 or 6 years. 5 or 6 years ago, he built that house.
Yes,
and he did make the comment, yeah, the clothes don't feel like they're getting completely dry. And he said that they usually end up running them a little bit longer, running another short cycle or something like that. But he did mention that, again, it's that perception of not being dry because of the temperature. Yeah. So yeah. My kids who take their clothes out of the dryer and just leave them in the basket for 3 days before they touch them, maybe they should start folding those right away instead of just leaving them piled up.
Next time, use a steam closet. That would be a cool product to talk to you about.
Oh yeah.
Oh yeah. I want one.
Yeah, so I love LG. All of LG's laundry products have really been fantastic. Actually, we've been promoting those to our customers for the last few years because the laundry towers that you guys make are really fantastic products. Not the heat pump. I haven't installed the heat pump unit yet, but the traditional electric laundry towers are really great products. Mm-hmm. So one of the things I've heard also in the past, again, this technology is evolving, is that the capacity on these units on the heat pump dryers isn't as large. But I was actually doing some research before our podcast today, and I was surfing the LG website, and I saw that you guys have it's like an 8-point-something cubic foot, or maybe it was 7.5 or 8. Oh, here it goes, 7.8 cubic foot dryer now, which is a pretty standard size dryer, or even on the larger side. Now there's some of the electric and gas companies that have like a 9 cubic foot behemoth, but a 7.8 cubic foot dryer is a pretty typical size clothes dryer. So that argument of they're not as big, not as high capacity as the other technology that's not really an argument anymore.
No, not any longer. Yeah. I mean, your typical European or Caribbean market product will be much, much smaller. That same thing goes for the stove. That same thing goes for the fridge. That same thing goes for the stove. The same thing goes for the fridge. It goes for the washer and dryers, right? They just have a lot less space to work with. We're in America. We're in Texas. Everything's bigger, baby. So yeah, having the ability to have that 5 cubic foot washer, the 7.8 cubic foot dryer, heat pump, it just gives you, again, the ability to throw that, comforter in, wash it, dry it, without having to go and pay a dry cleaner. I wash my comforters at least like every other week, but
yeah,
about other folks. But it gets pretty expensive if you can't do it on your own.
Yeah. For builders who are looking to adapt more of this technology into their products, into their new homes, at least for custom builders, I can speak to specifically because that's what I do. We have to have these conversations with our customers to convince them to use certain products. We can say, hey, our standard spec is to do this, but a lot of times the homeowner is still going to say, yeah, but I want gas. I've always had gas. I want gas. Or I want regular electric. I don't want that heat pump stuff, right? So we have to guide people and give them the information to make these decisions. So how would you recommend that builders approach this with their clients without coming off especially in the Houston market, without coming off as, too greeny or too, anti-gas. We've touched on some of this already, but kind of to wrap it up, what do you, what is the most compelling argument for builders to make with the homeowners about making these transitions?
Health and resiliency. It all comes down to health and resiliency. I've said it 100 times. I'll say it 100 times again, in the next week. Is the gas we cook with today any different than it was 30 years ago? No, it's not. So why is it all of a sudden a health hazard? Because we build homes tighter.
Right.
Energy costs more. So to keep more energy in our pockets and in our homes, we have to build them tighter to keep that energy from flowing out. By building homes tighter to keep the energy from flowing out uncontrollably, we now keep more of the bad stuff in. So the less bad stuff we introduce into our homes, the healthier our indoor environment becomes. The cheaper it becomes to clean that air, to keep it filtered, to keep it fresh, right? We know that indoor air is far more polluted than outside air. Why? It's because we live in it. Every home is perfect. It's perfectly built, perfectly people in it. And we as people just screw it all up, right? Because we all have our own preferences. We are the cause of mold and mildew in homes. It's not the home, it's us. It's how we live. And you can't get around that, so you can control for it. Health is a huge aspect, and is something that I would absolutely approach first with home buyers, is educate the home buyer on what are the health benefits. Why do we build the way we build now? Secondly is resiliency. Like you said, you don't want to come off as greeny. I don't want to come off as greeny. I'm not greeny, right? I don't want to electrify my house so I can hug some trees. I like trees. I don't have anything against them. They give me nice shade. You find a nice, true oak, not these spindly oaks we have down here in Houston, but like a real oak with big leaves, and sit down underneath it in spring. Man, it sounds like magical, right? But that doesn't mean that I want to build my house around the fact that I want to save a bunch of trees. But if I can build my house to be comfortable, if I can build my house to be resilient so that no matter what happens, me and my family are safe. We're cool in summer. We're warm in the winter. We're comfortable. We have water. We have food. And I save a couple of trees as a result of that. I'm not mad.
Right.
Right? So let's just approach it by being honest and by educating. And if a consumer insists on having gas and that's what they want to go with, more power to you. That's a beautiful thing about this country is we have options.
Yep. It's not for everyone, and we can't force you into it.
Nor would you want to.
No.
It's just an option. And if we present it as an option, people do take it. And it's crazy. NAHB did a study in 2019. Their own study showed that 75% plus of consumers were willing to pay 18% or more premium for a healthier, more efficient home. Now, I don't know why NAHB keeps fighting that. It's their own study, and it benefits them as well. But then they also did another study, roughly, I want to say maybe a year and a half, 2 years ago. And that particular study asked consumers and builders, if you picked, and they had a list of 15 different improvements, on what would you pay more money for in your new home or a retrofit of your home? What are the highest priority things, or the things you would spend the most money on? And guess what the top 3 things were?
Air conditioning?
Heat pump air conditioning,
yep.
Heat pump water heater, and solar. Solar came in third.
Wow.
People are more likely to spend money and install an efficient heat pump system to keep their home cool and hot, a water heater that's heat pump operated, than they would solar. And then very, very close after that was heat pump washers and dryers, things like that. But heat pump technology is on everybody's mind. So they did another study and said, hey, you know what? We want to find out about our builders. What are they willing to put in to make a home more efficient and more attractive to the millennial buyer? Guess what the top 3 were? Heat pump space heating, heat pump water heating, solar.
Wow.
I mean, we're all talking the same language. Consumers are asking for this. All we have to do is educate them and show them that it's an option. If we don't tell them that it's an option, then of course they're not going to buy it. They don't know we offer it.
Yeah.
So let's just talk to folks. Let's find out what matters to them.
I think so much of it is education, is builder education, right? Because, I would bet that a lot of people doing that survey are a lot of production home builders, because I've actually seen a lot of production home builders be much quicker adopters of some of this stuff than custom builders. I think educating custom builders and like spec home, kind of semi-custom builders is really the challenge. And, and maybe we aren't as big a market as production homes, right? But our buyers typically have a lot of money to spend. But I find I'm going to make a big generalization here. Most custom home builders are not well educated on this stuff, and so they're more likely just to say, "Gas is better." Gas stoves are better. Gas furnaces are better. It's what I've always used. It's kind of more of that curmudgeon attitude, so to speak. And I say that because I'm a custom builder. I'm on GHBA board. I'm around a lot of other custom builders, so this is what I hear. I go to education events for the Builders Association, and this is the mumbling that I hear every time electrification is presented, every time new technology is presented. I hear this grumbling of, that's greeny weenie stuff, that stuff. People in Houston want gas. So really, all that to say, I think the biggest battle that we have is educating custom builders, remodelers, spec home builders, because the production builders have already been educated. That those guys on a national level are already going this direction, right? So the more that hopefully we can do as a podcast, the more that you can do as a rep for LG, the more these companies can do to educate custom builders, the better off we're going to be, and the more this stuff's going to get adopted for the market that we're in.
That's actually, that's perfect what you just said. My job at LG is not to sell LG products. My job at LG is same as it was at the previous company. My job is to educate, to advise, and to help folks find the most efficient way to arrive from point A to point B. And if it's so, and during that process and during that journey, they look at it and go, "Oh, you have products that fit this need. Great. Here's a number. I'll put you in touch with my folks, and they can sell you the product you need." But my job is to educate them. And I would also actually go back and say, I don't think that majority of custom home builders are uneducated when it comes to this. I think they are miseducated. And the biggest culprit in that, and I'm going to call out my own industry, we are the biggest culprit, because we have spent decades building systems and plans to produce those systems, and change costs a lot of money. So a lot of times we miseducate, sometimes due to our own ignorance and sometimes due to whatever reasons there may be. We miseducate builders and consumers into, "Oh, this is just bad. You don't want to use this." Why? Because someone else is making it? Because it's going to cost you a lot more money to switch over? But to your point, production builders are moving in the direction, not because they want to be greeny, but because they have a lot of money, and they don't look to the next project and the next 10 projects or even the next 5,000 projects. They're looking 5-10 years from now. They're looking to see, because they're mostly publicly traded companies, they need to continue growing. They need to continue showing profitability. So they spend a lot of money to research market trends and see where things are moving.
And they care about what the consumers want. They look at those surveys that you mentioned, and they see the people want solar, they want heat pump systems. They see that, and so they start speccing it.
Who were the first companies to start bringing you in subway tile and white cabinets? Production builders.
Right.
Who were the first companies that backed away from subway tile and white cabinet? Production builders. And it's crazy, because about 6 months to a year after they switch everything away, you start reading articles. White cabinets and subway tile no longer the how it was 2 years ago. It's like, yeah, they're ahead of the game because they're interviewing people. They're constantly surveying people. They have marketing departments whose sole job is to do nothing but to talk to people who will be buying homes, and not now, but 5 years from now. They're talking to these young kids that are just now in high school, because they're looking at it going, 5 years from now, you're going to be home buyers, and we want you to be our home buyers. So what do you want? That's all we got to do. We got to educate custom builders because like you said, your customers have money. Your customers had a choice. They could go to a production builder and get whatever they get, or they can come to a custom builder, get a better quality made product, made exactly the way they want it, so that it's built around their lives and they don't have to build their lives around the product that they're buying, a home. We just have to educate them. Like, who would in their right mind sit there and go, yeah, don't worry about the air I breathe. That's not important. Just put whatever you can. Make sure I get this really pretty $30,000 granite countertop. That's the more important piece. Why did they pick it? Because every single showroom I have ever gone to, and trust me, I've built several houses for myself through various different builders, and I've built one on my own. But every showroom I go to, I have choices. Tiles, carpets, finishes, paints, granite countertops, lighting fixtures, doorknobs. For crying out loud, the trim along the carpet, I can pick and choose whatever I want, however I want it. There's actually two pieces that are never shown, I never see, and I never know that I have a choice on. Air conditioning, heating, water heating. They're just there somewhere.
Yeah.
All I know is I got cool air and I got hot water. That's it.
Yeah. You only care about it when it goes wrong.
Yeah. Give them a choice. Educate the consumer. Like, one thing that we've started doing as a manufacturer is we spend our time to educate the home builder and the salespeople in the home builder's office. They need to know how to talk about these things because no one's coming in and educating them. How can we expect them to educate the consumer? So it's like we as an industry have to do a better job. We're trying to, and as the generations change, millennials are the biggest home buying block right now. Gen Z will be a very big home buying block within the next 5 to 7 years. They are very educated. They grew up with a computer attached to their hip. Everything they need to know, they can ask ChatGPT or Gemini, and it'll give them the information. It's like you go out and you look up and you just search some things now on Google. Man, that Gemini comes out and gives you the information. You're like, wow.
Yeah.
Like, I'm an expert at Google, and I can't find that stuff, half that stuff that it comes up with. So these folks are educated. We have to be just as educated as they are so that we can continue being relevant.
Yep. So when they ask us the questions, we appear that we know what we're doing, and hopefully we do it.
Or at least we do know what we're doing. And grab a phone and look it up. You know,
exactly.
We have the same power that they do.
Yeah. There's no reason to be ignorant these days with all the information that's at our fingertips.
Absolutely not.
So, I mean, education is one of the big reasons that you know, we're here doing this podcast. It's the reason I started this. It was, you know, we wanted to educate home builders and homeowners about, you know, the right way to go about building a custom home, remodeling a home, or choosing the right products to go in the home. And that's why we're here.
Absolutely.
So, Voya, thank you so much for being here again with us. I know that we'll have you back again to cover some of these other topics sometime very soon.
Yeah, for sure. I'm more than happy to be here. Like I said, I'm a building science geek at heart. That's what I do. That's what I love. So anything that I can do to help, not just to help spread the news that I learn at these events and places that I go to, but there's a lot of things that I learn from these conversations as well. You know, it helps me be more efficient and better at what I do. And I think it's a really good thing. So yeah, I would be more than happy to come back and we can talk about a lot of different technologies because crazy stuff is happening, man. I mean, you know, heat pump technology, we think like, okay, yeah, we figured it out. It works. It's great. No, it's like there's products coming down the pipe that are good to like -40. There are products coming down the pipe that are using AI to optimize their processes and to optimize how efficient they are and how they operate.
Oh, man, that's fun.
There's products that are coming out that are like, you know, our products are capable of using solar as it's converted. But there's products coming out that can literally like have onboard solar and onboard batteries. There's so many different things that are just coming down the pipe right now because it's what consumers are asking for, that it's going to make our lives just that much better, that much easier, but also that much more complicated. And we have to stay ahead of it.
Awesome. Are you going to be at EBA here in a few weeks?
Yes, I'm going to be at EBA, or at least I think I'm going to be at EBA. I'm supposed to be there. There's like 17 out of my schedule right now.
You're going to all of them.
Yeah, I'm going to be everywhere from KBIS, IBS, EBA, and everything in between.
Yeah, so we'll have to catch up again at EBA like last year. Go eat dinner again.
Yeah, absolutely. Let's eat dinner. And I mean, heck, let's bring some mics and let's go let's go talk to some folks out there, because there's a lot of smart builders and a lot of smart folks at EBA, and believe it or not, like when I looked at EBA and the membership of EBA, which for those folks that don't know who EBA is the Energy Efficient
Building
or
Alliance.
Energy and Environmental Building Alliance. It's basically a bunch of builders that build really, really well-built homes and have kind of made a pact to say that, hey, you know what? We're not going to hold these secrets to ourselves. We're going to help each other, and we're going to help industry be more profitable and build it better. A lot of those guys are from Texas.
Yeah.
A lot of them are from Texas. It's like I started looking around like, we are a gas capital of the world, but baby, when it comes to electrification, we're doing better than most.
Yeah.
And we're just doing it quietly. We're just sneaking in.
So last year was the first time that I've been to the EBA conference, and I'm excited to go back this next year and learn some more.
Yeah, it was my third. This will be my fourth, and it's always a great learning experience.
Cool. Look forward to seeing you there.
Absolutely.
All right, Voya, thanks again for coming, and thank all of you guys for checking out the Your Project Shepherd podcast. Thank you for being with us today, and we will see you next time. Bye-bye.